Welcome to example 7. In this particular example, we're going to look at the integral from 1 to 5 of the function 1 over x plus 1 over x cubed dx. So all of this is what we're integrating with respect to x. Here over on the right is a picture of that function. You can see it's got sort of a piece over here on the left that we're not too concerned about because we're integrating from 1 to 5. So 1 starts here on the x-axis. We're going to go over here to 5. So we're finding the area of this blue region, which is above the x-axis. So it's all positive area that we're computing. Now, this example is a little bit different because these two pieces of the function look very similar, but they're not. We know that the integral of 1 over x from the previous example is the antiderivative of this is the natural log of the absolute value of x. That works only for 1 over x. It doesn't work for 1 over x cubed or 1 over x squared or anything else. It only applies to 1 over x. If you have this kind of function, you cannot apply the natural log rule. You have to think about how to rewrite this function so that another rule would apply. So what I'm doing here is I'm going to rewrite x to the third as 1 over x to the third, rather, as x to the minus 3. So I'm using rules of negative exponents. In this case, the opposite of how to get rid of a negative exponent would be to how do we move a positive exponent down here in the denominator up to the numerator, and we would do that by switching the sign on the power of the 3. Another way to think about this is just to check this. How would I simplify this expression so that it did not have a negative power? I would write that as 1 over x to the 3, which is what I'm starting with. But I also rewrote 1 over x as x to the minus 1. So you could see that when I go to take the integral of this, if I were to think about using the power rule, where n is negative 1, x to the n, hopefully you would remember that the power rule for integrals does not apply when the power is negative 1. That was the only exception to the rule. And so we had an alternative rule there, which was if you had x to the negative 1, we would think about it as 1 over x, and then the antiderivative of that is the natural log. So we got to be a little bit careful here that we don't mix up those two rules. But if we think about this as being associated with the natural log, and we think about this second term, x to the minus 3, as being associated with the power rule, then we can find the antiderivative of both of these two pieces. When we do that, we would say the antiderivative of 1 over x is the natural log of the absolute value of x. And then when we go to take the antiderivative of x to the minus 3, remember, we have to increase the power by 1. So negative 3 plus 1 gives me negative 2. And then I have to divide by that new power of negative 2. So this entire expression is the antiderivative of this beginning expression. And then I'm evaluating that antiderivative from 1 to 5. The fundamental theorem of calculus tells me how to do that. And the rest of the calculations are really just arithmetic. It may be that I want to rewrite these expressions a little bit so that they're a little bit easier to evaluate. So for example, this x to the minus 2, I might want to bring this down to the denominator so it's a little bit easier to calculate. It's not required to do that. But if I wanted to, I would just bring x to the minus 2 down to the denominator and make it x to the positive 2. Now, I'm not moving the 2 up because the power on the 2 is a 1. So if the power is already positive, you don't get to move that. You're only moving pieces of the fraction where the power is negative. So x to the minus 2 gets to move downstairs to the denominator, but negative 2 to the positive 1 has to stay there. The other thing I've done here between these two expressions is I've taken this negative 2 here, and I've simply just kind of put it out in front. Not required again, but it just makes the calculation of this expression a little bit easier. So I can plug in 5 and 1 into the antiderivative separately. So when I plug in 5, I get the natural log of x is the natural log of 5, minus 1 over 2x squared becomes 1 over 2 times 5 squared. Then the fundamental theorem of calculus once again says subtract, we always subtract, the antiderivative evaluated at the lower limit of integration. So that means we're going to put 1 into this antiderivative. So we have the natural log of 1 minus 1 over 2 times x squared, or 1 squared. The rest of this is basically just going to be calculator driven. So when I do this, I'm going to end up with approximately 2.089. And so this represents the area of this blue shaded region. It's all positive area. And so the area between 1 and 5 of this original function up here with an antiderivative of this, that area is equal to a little bit more than 2.